Hi guys, welcome back again to Math 135. Today we're covering section 1.4. This is the fourth day of learning stuff. And it's pretty obvious where we are because it's section 1.4 and we're doing day 4 of learning stuff. So today we're learning about functions, what makes a function, what the domain and range are. And a side note for you guys, normally I try to follow the book as closely as possible so that you can watch my videos and then you can go to the book and read it, then you get the same stuff reinforced. This week, because I was looking at the objectives and it didn't seem to match up perfectly with what we're learning, I changed the objectives for my notes slightly. So these 4 objectives that we're covering today are going to differ a little bit from the book one, but the material is still going to be the same. I just have it organized a little differently, I guess. Okay, so number 1, what we're learning is how to use functional notation and find function values. Number 2, we're learning to decide whether a relation is a function or not, a relation or equation. Number 3, how to find the domain and range of a function. And then number 4, how to get information about a function from its graph. So those are the 4 things. In this first video, we're going to focus on functional notation and then finding function values. Pretty easy stuff, but it's kind of fundamental to understand what a function is in this first video. Okay, so before we begin, we need to know what a function is. And here's what the book says. It says a function from a set X. So set, by the way, is just a collection of stuff. And in this case, we're talking about a collection of numbers. So we've got a collection of numbers, big letter X to represent, we've got a bunch of little numbers that go inside of that set, right? Function from a set X to a set Y. And it is a rule. Different places will call that a different thing. They'll say a rule or relation or some maybe operation or something that assigns to each X element one element of Y. So this exactly one thing is an important distinction. You can have relations that assign more than one element of Y, but then they aren't functions anymore. So we call the set X the domain of the function, and then we call the set Y the range of that function. So the set Y corresponds to all the elements of X. That means the function takes you from X to Y, right? And in order to be in the range, there has to be an X that gives you the Y that you want, the thing that's inside of that set. So real quick, let me draw you a quick little illustration of what's going on here. We call the function f, right? Oops, it's way too thick. So we call the function, let's say we have a function f. And what this function does is it takes you from this set, represented by this circle here, the X, to the set Y, right? That's what it does. Okay, let's look at the next part, the functional notation. So functional notation, use functional notation to find function values. In functional notation, we often use single letters such as F like we just saw, or G or H. But there's nothing really actually holy about these. We could just use these by convention, but you could use different letters. Like in physics, I know I use a lot of other letters like V for velocity or A for acceleration, for instance. So you don't have to stick to those. You could also use capital letters. Some books will use capital F, G, or H, or other things. They sometimes mean different things. Anyway, the standard one is the F, though, right? That's what we probably remember from middle school. The notation f of x represents the value of the function f. So f is the name of the function, and the f of x is the value of that function when you put x in. So coming back to our little picture here, right? F is this function that takes you from the set x to the set y. And within this set x, there's all these little values, right? Here, x1, x2, x3. These are your little individual values. And then they're mapped from x to y. So this little x2 becomes a y2. Little x1 becomes a y1, sorry. Little x3 becomes a y3. Or you can think of these guys, instead of calling them y3, y2, y1, you could think of those guys as f of x1, f of x2, f of x3. So f of x1. This is f of x3. That's the notation that we're using. Okay. Okay, that's that. Let's try questions 1 and 2 already. So let's go down. I have it all prepared here. Learned from my previous videos to have it prepared in advance. So question number 1, this was the original question. It said, okay, let f be this function, g is that function, h is that function. And it tells you to find f of 0, g of 0, h of 0, f of a, f of negative x. That's question number 1. Question 2 is similar, but they give you different values. Okay, so let's go. I have those copied over here. So here are those functions, right? Starting with f of 0. So here's f of x. What is f of 0? Well, super easy. All you do is you just input wherever you saw an x, you're going to input the particular value that we have in mind, which is a 0. So let's draw that slightly nicer. I'm just going to put a 0 there. And okay, one thing that helps to make sure that things are organized is to just put your input value in parentheses. I know this is not really necessary here, but this helps especially when you start putting in a negative or when you have like a input value that's more complicated with maybe letters and numbers or something like that. So my recommendation, just keep that input value in its own parentheses. 3 times x or 3 times 0. Okay, super easy here. 0 squared is 0. 3 times 0 is 0, so 0 minus 0 plus 1. And the end result is just a 1. So there's your answer. F of 0 is equal to 1. Okay, we move on to g of x, and now we're also doing g of 0 here. So same idea here, right? Here's my g of x. I'm going to take g of 0. That means wherever I saw an x, I'm going to replace it with a 0. And my recommendation, again, just keep that 0 in its parentheses. Okay, what's the square root of 0? Well, 0, okay. So that's going to be 2 over square root of 0. And what's the square root of 0? Oh, I just repeated myself, sorry, and I wrote the wrong thing. Square root of 0 is 0, right? So I have 2 divided by 0, but that is not possible. That's one of those undefined situations. You can't divide something by 0, so it's undefined. So what's the answer? What is g of 0? It's undefined. It's not a number. Okay, moving on to h of x. So here's my h of x function. And again, I'm doing h of 0. So I'm going to say h of 0 is 2 minus 0, and then the square root of that overall thing, right? Okay, well, that's the square root of 2 minus 0 is just 2. So it's the square root of 2, and that's it. You're done. Square root of 2. You can't reduce any further than that. So h of 0 is the square root of 2. Okay, now there are 2 additional questions, right? Find f of a and f of negative x. Okay, so we're coming back to our f function. All right, and I'm just going to erase this thing here so I can make space for the new one. Let's do it purple now. So this is going to be f of a now I'm going to do. So f of a, wherever I saw an x, I'm going to replace it with an a. Okay, here I'm going to disobey the... No, I'm going to do it in 2 steps actually. Input in parentheses first. Just to get used to doing this. Because, like I said, sometimes if there's something more complicated, then it's helpful to have that parentheses. But, it turns out that parentheses was really not necessary because a squared is a squared. 3 times a is just 3a. Plus 1 is just plus 1. So I could have skipped this step, actually. But this is just, getting used to doing things a certain way so that my life is easier later. But this is the result. Yeah, f of a is just a squared minus 3a plus 1. So whatever a is, that's where it goes. And it's squared, and here it's multiplied by 3. And then you add 1 at the end. Okay, one more part for question number 1, which is that f of x, negative x, sorry. So let's do that one in orange. Delete again to make space. Oops, you're seeing my erasures there. I erased using a white pen earlier. Okay, said it was going to use orange. So now we're doing f of negative x. This is something we actually did earlier in the section where we're talking about even and odd functions, yeah? So here's an instance when it definitely helps to have that parentheses there. Negative x squared minus 3 times negative x in parentheses plus 1. Sorry, that's kind of blurry because it's zoomed in a little too far. Okay, so... But now I'm getting peeks of that other question, which I don't want to see. So, okay, so now all we do is we simplify. So what is negative x squared? Well, this is negative times a negative, and it ends up being a positive x squared. Minus 3 times negative x, minus 3, negative x multiplies together to be a plus 3. So you get plus 3x and then plus 1. And so there it is. X squared plus 3x plus 1. That's f of negative x. Okay, question 1 finished. So now let's move on to question number 2. The same f, g, and h functions, but now I'm just checking different values. -1, -1, -1. Then I'm doing h of c and h of negative x. So very similar to the last question, just different values. You notice they use c this time. Last time they used an a. So it's kind of very similar, although this time it's for the h function. Yeah. Okay, let's do the same thing again. F of -1, let's kind of speed things along here. F of -1 is -1 squared minus 3 times -1 plus 1. -1 squared is 1. Minus 3 times -1 is going to be plus 3 and then plus 1. So 1 plus 3 plus 1 is 5. Okay, switch colors here. G of -1 is going to be 2 over the square root of a -1. And again, we have something that's undefined because you can't take a square root of a negative unless you introduce imaginary numbers, but we're not talking about imaginary numbers right now. So it's 2 over... Actually, I'm just going to stop before I even get there. This is already undefined because you can't take a square root of a negative. At least not in the real world. With the well, I shouldn't say real world. I should say at least not with real numbers. Okay, h of -1 is going to be square root of 2 minus, and here again, great instance where I should include my parentheses. That's the square root of 2 minus -1. That's 2 plus 1, right? Minus the negative is plus. So it's the square root of 3. And there it is. H of -1 is square root of 3. Great. Okay, now the last two problems. This time I'm going to do h of c and h of -x. So I'm focused on... What if I can cut and paste this thing here? Oh, yes, it worked. Okay, sweet. So this is what I'm focused on here. Looks like it's getting blurrier as I copy and paste more. Sorry about that. Okay, we're almost done. We just got these two things to check, right? H of c and h of -x. It's going to be easy, guys. Don't worry. So h of c, super easy. I'm going to skip that parentheses step. Just replace x with a c. That's it. H of c is 2 minus c. Square rooted. That's it. Done. Easy. Okay? So that was h of c. And then for h of -x, it's going to be the square root of 2 minus -x, which is the square root of 2 plus x. That's it. So that's the answer. H of -x is square root of 2 plus x. I should say it's square root of 2 plus x. Okay, guys, that's it for this first video. I'll see you in the next topic in the next video.